Today we're going to look at the start of Unit 2B, solving quadratic functions. Up to this point, we have only worked with the characteristics of quadratic functions, as well as setting ourselves up to be able to solve for quadratic functions. But if you remember, we've only been dealing with quadratics in terms of expressions. We haven't been necessarily solving for x. We're going to start by defining some really important words that will help us in order to be able to simplify radicals. Because remember, we're not going to be using the calculator a ton. Real numbers, which we can denote with the R symbol, is a value that represents a quantity along a number line. Seems like a very generic definition, but it's really most of the numbers that you've been working with since you first started learning your numbers. So this includes your integers, rational numbers, etc. So if you go back, this is probably something you did in 7th plus. Rational numbers can be denoted with a Q. Rational numbers are any number that can be written as a fraction. And irrational numbers, which I've actually never denoted with a symbol, but I did look it up for you. It is with a P. It is a number, and it's a real number that cannot be written as a fraction. Pi is definitely one of the most popular examples of this, but if you think about radicals, which you know that's where we're heading, if anything that's under the square root symbol, that's not a perfect square. So the square root of 17 is an example of an irrational number. If we found its decimal value, it would go on forever and ever, but it wouldn't have any repetition. We also talked about integers a bit up top, so just remember integers, if you ever see the Z symbol, that is the symbol for an integer. We are going to be heading into numbers, complex numbers that have imaginary answers, so we will get into that within this unit as well. The first thing you have to be comfortable with is simplifying radicals. We're going to be looking at the quadratic formula, which I know many of you already know, but we're not going to be using the calculator to help us simplify. So we have to be able to simplify radicals so that we're getting exact answers. Decimals, which we would get from the calculator, are only an approximation. So we're going to start with the square root of 75. We know 75 is not a perfect square. You have a couple of options for simplifying with this. The first option is to think through what perfect squares do you know multiply to make 75, or what factor of 75 could be a perfect square. So option 1 would be to show 25 times 3, which we know multiplies to 75. I can then separate each of these into their own radicals. So the square root of 25 is 5, and then the square root of 3 has to remain as it is. This gives us a simplified answer, and it's still an exact answer, not an approximation. Another option, especially as you get to bigger numbers that you can't think of a perfect square that may go into it, is to write down the prime factorization. So I know 75 is 3 times 25. 25 is 5 times 5. Underneath there is the prime factorization. You first started learning these probably 5th or 6th grade with factor trees. For each pair of 5s, or each pair of any number that you have under the radical, you can pull 1 out front. So I'm going to pull that 5 out front and leave the 3. That's always a good option to go back to if you can't think of a perfect square. In number 2, I have the square root of, or the negative of the square root of 72. Now that negative is on the outside, so that's legal. If it was inside, remember that we would have a problem because we can't take a square root of a negative. So this negative square root of 72, that negative is going to stay on the outside. Let's say you get to the point where you know it's going to be 8 times 9. Well, I know the square root of 9 is 3, so I can pull that outside the radical. Just because you've gotten one perfect square outside does not mean that you need to stop. You need to think through and go to square root of 8. Is there another perfect square? And there is. 4 times 2. So I can take the square root of 4, which is 2. So I pull the 2 outside with a 3, and I keep the 2 underneath. Outside, you're going to multiply negative 3 times 2. It's negative 6 square root of 2. If you had thought through what is the biggest perfect square that goes into 72, you might have noticed, oh, 36 goes into it. 36 times 2. Square root of 36 is 6. So that would have been one way you could have gone quicker. But if you don't notice that 36 went into it, or for a future problem, you can continue simplifying as you go. Number 3, the positive and negative square root of 54. So again, you can start to try to think through what are some of the numbers that I know go into the square root of 54 that might be perfect squares. If you don't know a big one, you can always think through some of your smaller factors. I know square root of 54. 9 times 6 is 54. Square root of 9 is 3. So I can pull the 3 outside and leave the 6 underneath. So this is the positive and negative values. Positive, negative 3, square root of 6. We're going to do one more together. Actually, we might do a few more together. Square root of 192. So as numbers start to get bigger, you kind of have to think through just how can you break it down. So one option you would have is to start your prime factorization. So that might mean you need to come to the side of your paper. That's kind of up to you. If I do 192 divided by 4, I know 200 divided by 4 is 50. So 192, there's 2 less 4's in there, so it's going to be 48, and I know 48 is 16 times 3. So I certainly have not broken it down into its prime factorization, but I have found 2 perfect squares with the remaining 3 that will have to stay underneath. The square root of 4 is 2. The square root of 16 is 4, so I'm going to pull those both out at the same time. I still have the square root of 3 underneath. Remember that you need to simplify. 2 times 4 is 8, square root of 3. If you think back through this product is 64. The square root of 64 is 8. So that works out for us. We'll go ahead and do 2 more together. The opposite of the square root of 800. So I know 800 has a perfect square of 100 in it. So you can say 100 times, now I could write 8, but I know 8 is going to have a perfect square in it as well. The square root of 8 is not simplified. I'm going to go ahead and write times 4 times 2. So now I can pull out my perfect squares. The square root of 100 is 10. The square root of 4 is 2. And I still have the square root of 2 remaining, leaving me with the product. Negative 10 times 2 is negative 20, square root of 2. Again, perfect square right here, 400. The square root of 400 is 20. And number 6, I have 4 times the square root of 18. It looks like it might already be simplified, but if I think through 18, 18 does contain a perfect square factor. So I have 4 times the square root of 9 times 2. Square root of 9 is 3. So I can pull the 3 out. I'm left with a 2 underneath. So I have 12 times the square root of 2. I'm always a stickler about showing work, and this is exactly what I would expect to see. Even if you can think of the highest perfect square, show me the breakdown of the factors. I'm going to ask you to pause the video. Take a moment, try to see if you can do 7 and 10. or 7 through 10. Once you finish, come back and check your answers. Okay, hopefully at this point you've had a moment to check your answers. 27 broke down into 9 and 3, so I can pull a 3. Square root of 9 is 3. Pull that out. So you should have 15 times the square root of 3. For number 8, 7 times square root of. Hopefully you saw that it was 16 times 2. If you didn't see that, remember you could break it down into factors of 2, and for every pair of 2, you can pull out one of them. I noticed 16 times 2. Square root of 16 is 4, so I'm going to pull the 4 outside the radical. The 2 remains inside. 7 times 4 is 28 times the square root of 2. Number 9, 3 times the square root of 600. I know 100 is a perfect square, and it goes into 600. 6, its only factors are 2 and 3, so square root of 6 is going to already be simplified. The square root of 100 is 10. 3 times 10 is 30, square root of 6. And last but not least, number 10, this one probably took a little bit longer, and that's okay. This one, you might want to start breaking down into smaller factors. I went ahead and I first started and I divided it by 4. Because I know 4 times 112 is going to be 448. And I had to do all of this at the side of my paper whenever I was making my answer key. Then I did 112 divided by 4 is 28. And then I know 28 is 4 times 7. So for each of these 4s, I can pull out their square root. Square root of 4 is 2. Square root of 4 is 2. Square root of 4 is 2. Square root of 7 remains. 2 times 2 times 2 is 8. Square root of 7. You may have been savvy enough to notice 64 times 7 is 448. I'll be honest, I didn't see that right away. So for me, this method works the best, where I can break it down into things that are a little bit more manageable and not spend a ton of time trying to find the biggest perfect square. 11 through 13, we're going to just reverse the process. They've given us simplified radical form. If I wanted to undo it, what would I need to know? Well, I know each of these factors on the outside, I've taken the square root to get to that. So to undo it, it's going to have to go back. I already have the square root of 2, so that remains. If I put the 3 back, that's really like the square root of 9. You can either write 9, or you could write 3 times 3. Go ahead and multiply underneath. That's the square root of 18. Over here, I have the opposite of 5 times the square root of 6. Remember, we probably didn't take the square root of a negative. That negative just remains outside. So the negative stays there. Underneath the radical, I have 6 times. I have to put the 5 back, so it's really 5 times 5. So I have 6 times 25, which is 150. So it's the opposite of the square root of 150. Pause the video for just a moment. Try 13 and 14. When you think you've got it, come back and check your answers. In number 13, I have the positive and negative square root values, so I want both positive and negative answers. So that's going to remain on the outside. Square root of 10 remains. And then for each factor of 11 on the outside, I have to put the 2 back in. So I know 11 times 11 is 121, and then multiply that by 10. I have 1,210. And last but not least, 14, the opposite of 51 stays underneath. 2, square root of 4 is 2, so there's 2 factors of 2 in there, which would make my 4, which is the opposite of the square root of 204. It's really critical that you feel comfortable with these basic simplifying radical problems because we're going to get into much more complex types. There is some practice. Make sure that you ask any questions that you have.